Hi, I'm Carlos Spironelli Ramos. We have prepared a series of videos showing the new Medidenta's launch, the Genius Proflex endodontic files. First video explains the unique and customized heat treatment given to each group of the files in the series. Genius Proflex is the only file that has different heat treatments for each file in the sequence. The sequence of videos, we detail some important features that have been incorporated into the instruments. Then we show a sequence of videos showing step by step how to proceed instrumentation in standard canals, narrow and calcified canals, and enlarged canals. I hope you enjoy these educational videos as much as we love to develop this unique product. Let's start talking about the feature that gave the name for the Genius Proflex files, the progressive flex heat treatment. Let's take a look.
Medidenta Genius Proflex heat treatment.
Nickel titanium endodontic instruments have characteristics depending on the phase the metal is in. This is the nickel titanium alloy phases expression graphic, showing how the alloy can be transformed under stress forces or temperature.
Nickel titanium alloy can vary its crystalline structure under specific situations, leaving the metal temporarily or even permanently with different properties. Basically, nickel titanium files can be presented in an austenitic phase with superelastic characteristics, or in a martensitic phase, where besides flexibility the metal can be permanently deformed. There is also a transitional phase called R phase. From a clinical perspective, austenitic instruments have superelasticity, but cannot be pre-curved. This property is called the spring-back effect. Instruments in the martensitic phase have great flexibility and can be pre-curved. This property is called controlled memory.
Let's take a closer look at the transitional R phase. On this part of the graphic, you can see that there are different austenitic and martensitic proportions that can be permanently achieved on the nickel titanium alloy. This can be accomplished by doing an extra step in the manufacturing process called heat treatment. Therefore, you can have a predominant austenitic file, or even a predominant martensitic file, or a half and half austenitic and martensitic file. There are different endodontic files in the market that receive the heat treatment, leaving them with different austenitic martensitic proportions.
The question is, does a number 15 file need the same thermal treatment as a number 40? In other words, isn't a thin instrument naturally more flexible than a thick one? A small diameter file is certainly more flexible due to the lower metal mass. Small instruments are used in an early stage of instrumentation, and the dent-in-walls resistance opposes their action. Smaller diameters files can't be too brittle, otherwise they can separate abruptly. At the same time, small diameters files cannot be so flexible to deform without cutting, especially during the glide path preparation. Therefore, it would be more convenient to customize a heat treatment for thinner instruments, optimizing the austenitic phase, resulting in greater resistance to torsion forces. Flexibility already exists in it given the low metal mass. In the case of larger diameters files, different heat treatment recipes should be applied to progressively give more flexibility to the instruments, as these files by design show more metal mass.
It is shown in this test that equal diameter and taper files, but with different heat treatments, behave differently. The left austenitic file has less flexibility than the right martensitic file. By applying different customized heat treatments for each group of files, the result would be larger diameter instruments that are as flexible as smaller diameters instruments. Using one of the developed proprietary heat treatment formulas, the Genius Proflex files got the right balance between flexibility and resistance on the small diameter files of the sequence. The Genius Proflex smaller diameter files show an exact balance between strength and flexibility to create a safe glide path up to file 2504. Deformation will occur only if too much apical pressure is applied. Genius Proflex files with larger diameters, on the other hand, have heat treatment oriented more towards the martensitic phase, leading to greater resistance against cyclic fatigue forces. Larger but flexible files favor the proper final enlargement, even in cases of curvature. In this comparative test, it is shown that files without heat treatment tend not to remain centered in the canal when the enlargement diameter is increased. Genius Proflex larger files up to 6004, demonstrated high centralization capacity, without ledge formation.
Genius Proflex is the only set of files in the market that have different heat treatments customizations for each group of instruments in the sequence. The purple blade has more austenitic characteristics, which provide them with better performance in the initial enlargement phase. Instruments with blue and gold blades are more martensitic, being flexible and resistant to cyclic fatigue. It is very easy to identify the heat treatment applied. Check the Genius Proflex instruments package with the alloy phase expression bar.
Thanks for joining us in this presentation. For more videos and information, go to www.medidentaendo.com.